Hey everyone, welcome to a new episode in our Well AP series. This series is designed to help Well APs of all levels master the air concept within the Well building standard. And today we're going to take a deep dive into what I think is probably one of the very most important and fundamental parts of Well, which is the different verification pathways. And within the air concept, that is specifically performance testing and sensor data. Now, if you've been around Well for some time, you probably know that all Well projects are required, so it's a precondition, to test air quality annually. So that is feature A01, and there are different parts. There is more testing that must be done at the initial certification, and there is also annual testing that must be done to satisfy part 5 of A01. What you need to test for is particulate matter, so PM2.5, PM10, ozone, carbon monoxide, and either TVOC or a set of specific VOCs. Now, radon is also listed in part 4, but this part is automatically exempt if you operate a mechanically ventilated building, and essentially if you are meeting code, this is a precondition for A03, then this radon requirement will be automatically met, and you will not actually need to measure it. So all of the other parameters here are required to be monitored. And what this looks like, if you look at the Well standard within A01, you will see this little line at the bottom that says how your data can be verified. And this will be either through performance test or sensor data. So, what does a performance test mean? What is sensor data? In a nutshell, performance testing is having somebody, a certified professional, come to your building with a bunch of equipment like you see on the image on the left here, and actually taking readings at a specific point in time in your building. And this is typically a combination of monitors, as you can see here. It might involve taking samples of air quality and sending those to a lab. And this is very different from the image that you see on the right. On the right, you see sensor data. And in simple terms, this is just taking sensors, putting them on the wall, and measuring a lot of data over the long term. So this image is one way to look at it. Another way to look at it is this. A performance test is often what we call a spot check or spot test. And this is, as I mentioned, somebody coming in, certified professional, at a specific minute, taking a reading on a specific day of a specific year, right? So you get one data point. And that's kind of what you see on the image on the left. Whereas continuous monitoring is, as the name suggests, continuous. Readings are being taken potentially every few seconds, every few minutes, and you will see a much sort of longer period of data with many, many more data points. Now, there are big differences between these two approaches, and that's what we are going to walk through in a lot more detail right now. So first of all, the full disclosure, I personally have a bias here. I love continuous monitoring. I believe it's the future, and it just makes so much more sense in the era in which we live. And so I do have bias. That said, I will absolutely do my best to be completely neutral here, completely objective, and really give you the pros and cons of each of these methods. Let's start with performance testing. So probably the biggest benefit, and I'd say, well, first of all, we should say the reason why a lot of projects go with performance testing is just because it's the way it's always been done. Buildings, the Well building standard originally essentially required performance testing because a lot of technology was not able to do continuous monitoring. So there's a good reason, historically, this was the only way. That said, things have changed. We'll talk about that in a little bit. But starting with performance testing, one of the biggest pros is that it is sort of outsourceable. And what I mean by that is that you are engaging typically a third-party agency to come to your building for a finite period of time, maybe 1, maybe 2, maybe 3 days, and they're taking a series of measurements, and then they leave, and at some time, some period later, you receive a PDF or a stack of papers with a report that says what the readings were during those times. And this does not involve anybody else on your team. It does not, it involve multiple departments throughout the company. It's pretty straightforward, right? It's essentially outsourced and you receive something back. So that's a big benefit. Another benefit is that it is a sort of tech-free approach, right? you're not installing sensors. You're not actually physically putting anything on a wall that is going to stand there, that's going to stay there for a long time. You're not going to have sensors that are potentially connecting to your building's network, which would mean involving your IT department, potentially going through security review. And those things can take a lot of time in some organizations. And so, again, this sort of ties to the benefit of it being outsourceable. The third benefit is that typically performance testing, and again, this will depend on the approach taken, the parties with which you work, and the equipment that they use. Typically, this will have the highest specificity for VOCs and can also present the highest accuracy. What I mean by that is if we look at that one measurement that was taken on that day, typically you're going to be using equipment that is more accurate or able to measure parameters that could not otherwise be measured with continuous monitoring. For example, if you are looking to get a benzene sample, that is not going to be accomplished with continuous monitoring. Now, again, it's not actually required to measure benzene for the well building standard, right? You can go with the TVOC approach. But if you are looking to do that, the performance tests allow you to get a reading for that one very specific chemical, which you might be interested in. Those are the pros. The cons are that it can be extremely labor intensive. Performance tests have to be done by a few certified companies, which means that projects often need to schedule these way ahead of time. If you have a global portfolio, this can also very quickly become a complete nightmare. You can imagine, and I've seen this many, many times, you might have 30 offices across 20 countries. There's not one agency that is going to be able to perform the performance testing in all of those countries. So potentially you will need to go and, or not potentially, honestly, it's just pretty much a certainty. You will need to go and engage 20 different vendors in each of those different locations, maybe 30 different vendors to come in. So while I was talking about the pro of it being outsourceable, there's definitely a con, which is that you will need to outsource to many, many different companies. Once that data is brought back to you, again, it will probably be in 20 different formats of PDF with potentially in different languages. There can be a lot of work that is done on the side of the project, which is going for certification, to try and reconcile all of this data and sort of bring it all together. Also, coordinating each of these can be a huge hassle. There will need to be somebody typically on site or multiple people accompanying the performance testing team as they go throughout the building to take all of these different measurements. Right, they're not just going to be wandering with free rein throughout the building. Often this can actually also disrupt your day-to-day operations because you need to have people out of the building when tests are being done. Maybe you need to do specific things with the ventilation systems. Again, there's just a lot of complexity here. In 2 stories that I heard recently, one was a client telling me they had to fly a team from London all the way to Brazil to get an air sample from their building because they couldn't get the right performance testing service in Brazil. That is completely insane. Not to mention that even when you're thinking that many buildings that are going after well certification are often pursuing LEED, they care a lot about sustainability. The idea that you have to fly a performance testing team halfway across the globe to get a measurement to show that your building is healthy, that is completely bonkers to me. Another recent example I heard just the other day was a client who, this is a consultant and performance testing agent who is going to fly from the East Coast to the West Coast of the United States to take a measurement of temperature in a building. Again, we should be past the point where somebody needs to physically fly across the country to take a temperature measurement, in my opinion. And so, labor intensive, but of course anything which is labor intensive leads to costs adding up quickly. So the actual costs can be extremely expensive. We hear typically numbers between $10,000 and $25,000 to do performance testing for a single site. Now, in larger buildings, that can reach up to $40,000, $50,000, $60,000, and it is quite or extremely unusual for all tests to pass on the first go. So it's very common to budget for one test, maybe $20,000 budgeted, and you end up actually going through 2 or even 3 tests, right? So those numbers can very quickly add up. And I have heard countless stories of projects spending $30,000, $40,000, $50,000, $1,000 on performance testing for their building. And again, there is an annual requirement under A01 Part 5 to do these tests every year. So these costs can add up very, very quickly. Now, potentially the biggest challenge here, or the biggest con, is that at the end of the day, you're walking away with a single data point, right? It is a spot test. It is not continuous data for a long period of time. And so all this really tells you is that at the point in time where this measurement was taken, the air was acceptable or not. It is not giving you any insight into how this changes across the seasons, how the air quality in the building performs when outdoor air quality is changing, and many, many, many other factors that can really be very, very different over time. So that's the overview of performance testing. Let's take a look at the alternative, which is sensor data. So the pros of sensor data, well, until very recently, projects were actually unable to meet the requirement of A01 because there really weren't any monitors that could measure all of these different things. However, there are more monitors being created now. Technology has evolved a lot, and the well building standard has also evolved a lot to allow monitors like these to be compliant and to tick all the boxes for A01. Outside of A01, which is a precondition, there are actually many other features that can be supported through sensor data, and I'll talk through some of those in a moment. But the sort of the key takeaway here is that outside of the preconditions, using sensor data and continuous monitors, you can get up to 9 extra points within well. 9 points is a whole lot. It's a huge amount. This is the difference from that can take a project from being well silver to well gold, right? And that is something that is really worth taking note of because typically projects spend a lot of money and a lot of effort to take their project from silver to gold, but this is one single solution that actually allows you to get almost the entire way there, right, with these 9 points. Sensor data also saves you a lot of time, work, and money. Like I described in the performance testing section, it's a lot of trouble to have people come in every year to work with multiple vendors. If you are installing continuous monitors, this is really one single solution where a device is installed on a wall. It will start collecting data, and if you're looking at a global portfolio, again, of 35 offices in 20 countries, you only need one type of continuous monitor. You only need to work with one sensor partner to make that a reality. Of course, there will be work that needs to be done going through security review, working with your IT department. Some of that can actually be avoided now with sensors that stay completely off the network, which I can talk about in just a moment. But there is absolutely work that's required by internal teams in these projects to get sensors installed up on walls and reporting data. But compared to the amount of work that it takes every year to organize performance testing through all these organizations, it is a huge save. And I'd say what the most important one is when we talk about the pros, you get a complete picture of air quality. A single point in time of measurement of temperature is in no way representative of 4 seasons, 24 hours a day, day and night, ventilation running and not running. So this is the real problem that I have with spot checks. Again, it gives you one data point, whereas continuous sensor data is going to allow you to identify patterns, identify trends, and actually start to come to the root cause if there are any challenges with your air quality. If anything's not meeting your goals and you're not compliant for any reason, sensor data, continuous sensor data, will allow you to get to the bottom of why that's happening and fix those problems. So there is a huge benefit to having this data outside of just well. If we think about the ultimate goals, which are typically improving occupant health, productivity, comfort, employee satisfaction, these are goals that can be achieved through using sensor data that a spot check simply cannot help with. Of course, all of this is dependent on you choosing the right monitor. There are a lot of potential cons when it comes to sensor data. One is, again, that this is a tech-heavy approach. If the monitor is not easy to install, then everything that I said about saving time and money goes out the window, right? So if this is done well and you're working with a provider that does a good job with reducing complexity, installation time, installation cost, then this is a pro. If not, it can be a huge con. Another one is that most monitors cannot meet the requirements of A01. As I said earlier, there's a specific series of parameters that need to be measured in order to be compliant with A01, and not all monitors do this. I guess another con on that front is that you actually need to spend a little bit of time up front to really identify the technology that you want to work with, look through the spec sheets, compare it to the performance verification guidebook on WELL, and make sure that each of those lines match up, right? So that your monitor is compliant and it is going to do all of the things that you think and you want it to do. Because it is absolutely true that not all monitors will do this right off the bat. So I have one example here. This is the Kytera SenseEdge Go. Of course, it's not the only monitor in the world that can do this, but I'm just going to use this as an example of how this device can meet all of the criteria. So again, you're measuring, as you can see, PM2.5, PM10, TVOC, got CO and ozone. So those are the requirements for A01 Part 5. And then through some of these other measurements, such as NO2, such as CO2, you're actually able to get a lot more features. And so that's what you see on the table on the right here. With each of the features, you can receive up to 9 extra points. Something that we often think about is sort of a return on WELL points. Projects are generally trying to maximize their points under WELL, maximize occupant well-being for the minimum cost. And so being able to hit 9 points with a single solution is a really big win. As I said, the other potential con is that it can end up actually being costly, right? If you don't have the right monitor, it can end up being costly to install these. It can end up being costly to maintain these. It can end up being costly when you think about calibration and making sure that they're accurate over the long term. So there are a number of considerations. I've tried to list some of these out here to help anybody that is thinking about a sensor data pathway to identify sort of the right questions to ask when choosing devices. So number one is installation and setup easy. If it's a new building, you are probably going to be able to run wires at pretty low cost to power devices. If it's a retrofit, that can be very expensive. And so a battery-powered sort of peel and stick on the wall solution with double-sided tape could be a really good path. Is maintenance easy? So that could be things like changing batteries and how long the battery life on a device lasts. That could be keeping sensors calibrated or maintained. In case there's ever a failure with the device, how is that maintained? Extremely key, which parameters are being measured, right? The last thing that you want to do is install monitors that measure some but not all of the required parameters, because then what you're going to have is having spent money on continuous monitors, but also needing to run and perform spot tests every year and still use performance testing. So that's kind of, you're definitely not getting the best of both worlds if you're doing that. So make sure that you are measuring the right parameters and that you're compliant to be able to completely remove performance testing for error. Once you do that, that's when the costs really come down. How many WELL points can it achieve? And not all sensors are going to be able to deliver the same number of points within WELL. And that is obviously a really important metric as you're trying to get that WELL Gold, WELL Platinum. And is there any software support for data submission? This is a really important point, actually, that's often overlooked. Sensor data is great. It gives you a ton of data, which you can use to verify your compliance, and you can submit to the IWBI. However, if that data is not easy to prepare, it can be an enormous headache and actually end up being more costly. So an example of this, if you have 100 monitors in a building and you need to download all of that data, you need to format it and prepare it by yourself, you could end up spending 100 hours or more preparing that data. And many of those cost savings that I've talked about will just be out the window. And so here at Kytera, we have a huge focus on making sure that all of that is automated so that people don't have to spend time on it. Because otherwise, again, the math just doesn't end up making sense anymore. So if you have the right monitor, I'd say that going with the sensor data approach is honestly, and I know I'm slightly biased here, but it is more than 10x better than the performance testing. One final thing that I did not mention so far is that it gives you clarity on whether or not you're going to pass. I've heard from so many people this incredible anxiety that they have coming up to the date of their performance test because they don't know if their building, which they're trying to deliver in a few days or a month, they don't know if the building is actually compliant and if they actually have clean air. And they're basically waiting with fingers crossed, waiting for this performance test report to see whether or not their building is actually healthy, and they will be able to get their certification. With sensor data, that problem no longer exists because you can see every single day how your performance is as you come up to the data submission period. And if for any reason you're not compliant, you can go and make changes before you reach that sort of critical deadline. So, considering all of the labor and the manual work and repeated with tests that are necessary for performance data, sensor data can be more than 2x more cost effective compared to performance tests. And if you're doing a really large project, then the cost savings are even greater. I have a lot of information on the math behind this, so that was way too much detail for this specific lesson. But if you would like to know more about the math behind this, reach out to me on LinkedIn, send me a message, and I'll be happy to share what we have. Thank you, and see you on the next lesson.